Okay. Hi, everyone. My name is Ben. I have a small confession to make. I am not a JavaScript developer. This is actually my first JavaScript conference ever. Normally, I kind of spend my time speaking at conferences about APIs and backend technologies and PHP and other such nasty things that we do on server-side. But in the next 20 minutes, I want to try and answer a couple of questions. First of all, what is Hypermedia? And this is not a talk that's just about Hypermedia, but one of the goals of REST and Hypermedia is that it creates, by following those constraints, the RESTful constraints, it creates apps, it allows you to create apps that are evolvable, extensible, customizable, configurable, reusable, and all sorts of other superlatives, which I won't go into right now. What I also want to do is show some examples of what REST looks like. What does it mean? How do I make use of it? How do I make use of it in my apps? What impact does it have on how you approach building clients? And how can it change how you approach things? So, first of all, I want to say that there are two different types of API client. The first of which is the machine-driven client. So a machine-driven client is one which is a client which interacts with a server-side component, but it has enough logic built into it in order to actually make the decision what is the next appropriate and best thing to do. So if you imagine something that can talk to an API that's playing a game of chess, the server knows the rules of the game of chess, and the client can be built for that thing in order to be able to interact with it and create the moves, create whatever the next moves are. There's enough logic built into the client in order to actually be able to say what is the correct next step, what's the next thing I need to do. The other thing that gets kind of grouped in with machine-driven clients are language-specific API bindings. This talk is not about machine-driven clients, it's about the human-driven clients. So a human-driven API client is something along the lines of a smartphone app or a web application. Basically anything which is controlled by a person, which interacts with the server side to do stuff. But ultimately it's the responsibility of the human to make those decisions as to what that stuff is. So before diving into this too deep, let's consider how the web browser actually works. When a web browser makes a web request, there are two very important bits of data that come back from the server side. You've got the data, which is your header tags, it's your paragraph tags, it's the stuff that's inside HTML, which the browser understands as being the thing that it needs to work with in order to get stuff done. But it also comes with it also comes with what the client should do next. So that is your HTTP headers. It's, and another thing that's called affordances. Now, affordances are the things that are built into the data to describe, self-describe what that thing should do. So if we think about what should happen next, is you take a request, you get a whole bunch of information back, you get a head block. In that head block, there are links to style sheets, to tell the browser, well, actually, the next thing I need to do is go off and get that style sheet and use that in order to actually make this thing look pretty. Or not, if it was me that wrote the style sheet. It also contains links to scripts, linked to bits of JavaScript code, things that you need to execute in order to make this page functional. So it's metadata, it's code. It can be, but it can also take the form of links within that data. So things that humans have to make a decision on. So these little affordances, those little things that have meaning, and I'm going to go into a lot of those affordances that are included in HTML and how you can then apply those things to actual building actual real clients. Now, the canonical definition, written by Roy Fielding, the guy who I would say invented REST, kind of. He at least came up with the term and wrote it down on paper. And he says that Hypermedia is defined by the presence of application control information embedded within or as a layer above the presentation of information. So it's the data and how to use that data. and what you need to do next, what that data means, and how you can, and what the next step is. So let's take this as an example of an affordance that HTML provides. We have an anchor. And with an anchor, you can specify a URL. You can specify other bits of information about that URL as well. So you can specify a title. And what it does in the browser is it will render a little thing that you can click on, which will take you to that next step. The browser doesn't understand what that thing is, or it's left down to the human to make that decision. And this is an outbound navigational link. So the affordance that this anchor offers is outbound navigation. So you're taking somebody away from the page. Within HTML, we also have forms. These are essentially with method equals get, we have an action. We can create templated links. When you fill in the form, click submit. All the browser will do is take those things and it will append it to query strings and tag it onto the end of the URL. So we can create templated links using HTML. That's another affordance that it provides. With the image tag, you have the ability to be able to embed things within the current document. Again, it's another link. It's just another link, but because it's used inside the image tag, the browser can understand that actually what I need to do is embed it here. So you've got all these different types of things that are baked into HTML, which mean different things. The context of that URL, that image, is different depending on how it's used within that document. A browser is designed so that its hypermedia affordances are completely controlled by humans. So all of these things are just presentational. They're links that you can click to go somewhere else. There are images that gets embedded at this particular location, or it's a style sheet that gets used to render that particular page. But what happens when the consumer is actually a smartphone, or is a web application? The thing that thing is not directly the human that's actually interfacing with the API. Well, we could use HTML. You can translate those things into things that machines can read, but actually it's not really the best fit for purpose. And in the when we're designing and building APIs, we've created a whole wealth of different media types. There's loads of them, and there's loads of arguments all the time whether or not there is such thing as the one hypermedia type to rule them all. And there isn't. It all depends on what affordances that you actually need to have inside your application. Now, so this is an example of the hypermedia application language, or HAL, as it gets more affectionately known as. And this is a standard, and HAL actually contains two different types of link affordance. We have outbound navigational links, where to go next, which are you can see here. It's basically just a JSON representation. The standard says that all the links are defined as these particular types of object. You can see self, prev, previous, and next on the left-hand side. Those are the link relations, what they actually mean, what that link is, and then where to go on the other side. HAL also supports embedded, so a bit like your HTML's image tag. It supports embedded links. You can embed stuff inside a HAL document. This is really useful for doing caching. So if you wanted to follow one of these links, and you knew you wanted to do it every single time, you could actually just ask the server to embed it instead. So you can embed that link instead. The context is slightly different. And these two things allow that message to contain both data and context. How do I use it? What am I supposed to do with this thing? What it leads to is being able to say, well, actually, if the server can be put back into control of these things, if the server is actually making the decisions of what the next options are, then the client can be built so that actually it's a little bit more reactive to what those bits of information are. So we end up with less logic in the client, specifically business logic. When you have many different types of applications that are built for different devices, when you have web application or mobile application, even when you have mobile application, you're splitting out into iOS and Android. If you have business logic contained within all of those different things, you're going to have to put that business logic into three different places. And you have to make sure that all those three things are actually the same thing, because otherwise your business logic can be different depending on which platform you're actually using. And as this is a JavaScript conference, there's a handy little tip. I've recently been working on a project where we actually use this library. It's called hyperagent, and it understands HAL link types. It understands HAL, it can interact with it, and it gives you some really neat stuff for free. So given that representation that I showed earlier on, if I was to retrieve that from a server, from a web request, and I'm using hyperagent on my, in whatever client-side thing I'm actually building, I can interact with that using this kind of syntax. So I can say that response, links, whichever one I want, dot fetch. When I've done that, it just uses promises, so that it'll just it'll execute that callback once it's actually done the request. So you can this kind of tooling is what makes these standards actually really quite useful. The clients can adapt to change. What comes next is determined by links and relations, not hard-coded logic in the client application. Which actually, what it means is that the server can evolve independently from the client. So the server can start to move forward without the client ever actually having to change. In fact, a real-life example of actually doing this was when I've been working on a server-side component, and I've had my client-side developers building clients, but the bit that they happen to be working on is actually something that's didn't require the latest version of the client. So I'm kind of walking around the room, and there's like different versions of the client popping up on different people's screens, but all of it was carrying on working. Everything still worked because it was the server that's controlling what happens next, and there was no client-side logic. The evolution of the server didn't affect the clients. And a little note about URLs. URLs do not belong to a client. So if you find yourself doing something like this, where you're actually constructing URLs out of component parts, there's a good chance that that's going to be a bit of code that's going to break at some point in the future. Those URLs are really the property of the thing that served them up in the first place, and they should be allowed to change completely. If you're doing this, that stops that from happening. That stops that URL from ever being able to change. And there is actually a nice standard which HAL supports as well, called templated links, which allow you to do this really quite easily, especially when using hyperagent. It makes it really easy. You simply specify a link, an outbound link, as being a templated one. And you can pass in, let's see if this thing works. Yeah, so you can pass in a little templated parameter here. And when you want to actually construct the link, you simply pass in this template and the thing you want to swap in. Specify templated equals true, and away you go. In hyperagent, it looks a bit like this. So I can generate that link, that same link, rather than just constructing it myself. I can generate that link just by calling root link, the thing, templated link title. Oh, is that just fallen off or died? Oh, there we go. And pass in the value I want to substitute in. This is actually a standard, an internet standard. If you're really interested in such things, this is its number. It's not a terribly interesting read, if I'm honest. It's basically all you will ever need to know is what's in the last 2 slides. But there's about 60 pages of RFC on there if you look it up. All right, so the last thing that I wanted to talk about helping clients be reactive and evolvable is JSON Schema. Now, JSON Schema was something that was put into place in order to be able to validate JSON objects. Make sure that they contain the right bits of data in the right places, that they adhere to a certain type of structure. Really useful for validating stuff coming from clients. Also really useful for validating stuff coming from users. So because JSON Schema, again, is another standard, we can use exactly the same documents in order to validate input on the client side and on the server side using the same process. So we simply define one JSON Schema object, which looks a bit like that, again, JSON, containing specific properties, so title, type, the properties of what the schema should look like. So I'm saying I want first name, last name, and age. Which of those things are required in the request, and some information about how to validate those things. So here we've got age minimum, has to be a minimum of 0. And because these things are just JSON, we can just embed them into those responses. But it's not just about validating data. What you might have thought already is that actually, surely I could just start generating inputs from this stuff. And yeah, you can. There's a great library called JSON Form, or if you're more of the Angular persuasion, there's Angular Schema Form. They have a really terrible video on their website. Actually, it's pretty hilarious. You should check it out, Angular Schema Form. What these things do is they'll take a JSON schema, you pass it into these libraries, and it will actually render you a form, like that. It will also do all your validation for you. You can see at the bottom there, it says the form is valid. I filled it in. Age might not necessarily be correct. And this is entirely generated. What this actually means, though, is that the server is now put back in charge of what inputs are needed to be collected from the human that's using your application. You no longer have to change your client in order to accept new inputs in a form. Take those schema documents, use them to validate the inputs that are coming from your user, but also use them to generate those forms that are coming from the user. What you lose here is a little bit of control over what the user interface actually looks like. These libraries do provide some scope for being able to fiddle around with the layouts and do that, but you are a bit more at the mercy of what the server sends down the line. So what I've actually shown here is 3 good things. We've got Hypermedia, we've got link templates, and JSON schema. And all of those things actually just have one goal. And that goal is to put the control of the business logic back towards the server side, so that you can create more generic clients that can support those changes as they come through from the server. You don't need to have to redevelop all the clients just to support one new feature that comes from the server. If apps could react to the change in a positive way, then what we actually end up doing is creating these kind of more flexible, fluid clients, generic clients that can start interacting with more than one, perhaps start reacting to more than one different server that supports these different hypermedia formats. And that's the end of my talk. 2 minutes early. Thank you very much.